This short video outlines the process of installing the Optimizer 2 on the Siemens SP and SPS gas substation circuit breakers. These are popular breakers manufactured by Siemens through the 1990s. The basic difference between the SP and the SPS is the closing mechanism. The SP uses an air ram to close the breaker and at the same time charging the trip spring. The trip is accomplished by releasing the trip spring. The SPS uses a motor wound spring mechanism for closing and charging the trip spring. Again, the trip is accomplished by releasing the trip spring. Both breaker models are rated for 3-cycle operation. So why add the Optimizer 2 to a new circuit breaker? Today's breakers are so good that only a few measured parameters are needed to gauge their health. Using forecast info, gas refills can be planned when convenient and least costly. Gas emissions from leaking equipment can be recorded remotely and kept separate from handling losses. By assessing gas parameters remotely, the labor of a field inspection will be reduced. Begin by looking at the control cabinet. Look for a space that is easy to get to, easy to neatly run wires to, and close to the terminal block that terminates the bushing CT circuits. Preferably, the Optimizer 2 should be powered by station battery voltage, so that wiring should be accessible also. Some like to see the display through the cabinet window. This is often possible, but check to see that there is clearance so the cabinet door will close before you drill any holes. Another consideration is vibration. With the SP, there is an air compressor, and with both models, the close operation releases a lot of energy, so there is significant mechanical shock to the cabinet. It is best to mount the Optimizer with at least 2 screws or bolts to ensure a trouble-free installation over the years it will be in service. The ideal way to connect the Optimizer 2 aux-A timing input is to connect it in parallel with the trip coil. This gives the best information and will include trip time, travel time, and clearing time, all key indicators of mechanism health. The aux-B timing input should be connected to a wetted 52B switch or in parallel with the green light. With some modern protective relay schemes, trip coil monitoring is included. The protective relay function uses a very high impedance connection which can be rendered useless if the Optimizer 2 is connected across the trip coil, even though the impedance of the Optimizer is very high also. In this case, a separate trip output can be run from the relay that mimics the primary trip output. It should also operate when either trip circuit operates, if there are 2. This output should be wetted with DC and a resistor placed in parallel with the Optimizer 2 aux-A input to minimize electrical noise. Again, the simplest connection for the aux-B input is directly in parallel with the green light. The Optimizer 2 calculates primary current values from measurements on the secondary side. This makes it important to know the ratio of the bushing CT circuit you are connecting the pickup coils to. This value is entered into the Optimizer 2 as part of the setup process. The third step is to decide how you will connect the gas density sensor to the plumbing of the breaker. The sensor is always a 3/8" British standard parallel pipe thread. The sensor may be installed at the fill port, as you will see. It may be installed as part of a gas piping update, or a T-fitting may be installed in the existing gas piping. Schedule the outage in advance so things go smoothly. If the crew shows up prepared with all the parts, installation generally takes less than 2 hours. The SP and SPS have similar control cabinets, and there is usually plenty of extra room to install the Optimizer 2 main unit. The left-hand side of the cabinet is good because that is where the CT terminal blocks are, so routing the wires is much easier. With this SP breaker, the fill port was worn out, so the utility decided to update the plumbing by replacing the existing T-fitting with a 4-way fitting. A new run of piping was installed across the top of the control cabinet, then down to a bulkhead fitting installed on the bottom of the cabinet. The gas density sensor was installed along the left side of the cabinet using the fittings shown here. The extra fittings to include the sensor added about $90 to the total parts cost of the update. The sensor was tie-wrapped to the wire bundle for support. Before the piping job was started, the manifold was disconnected from each interrupter. Now that the new piping, new gas fill port, and gas density sensor is installed, the manifold is reconnected to the interrupters and tested for leaks with a sniffer and/or soapy solution. The gas piping system was purged of air by connecting the new fill port to a gas purity analyzer. When the gas purity hit a maximum, the system was again checked for leaks. After the purity analyzer was disconnected, the breaker was topped up to nominal pressure from a gas handling cart. Identify the bushing CT circuits and place the current pickup coils around those conductors. This CT ratio, referred to 1, is programmed into the optimizer when you set it up. Refer to the wiring diagrams for exact ratios and identifiers. For the SP, the CT circuits are located in a pull box on the left side exterior of the control cabinet. The twisted pair leads from the pickup coils can be fished through the existing conduit, cut to length, and connected to the CT inputs on the optimizer too. Mounting the optimizer 2 is easy. Standard quarter 20 bolts or self-tapping screws are ideal for mounting the optimizer 2 enclosure to the rear of the control panel. Tie wraps may also be used if a solid tie point or rail is available. Clean up the metal bits before you make gas connections to prevent impurities from getting into the gas system. Connections to the control wiring are made to terminal blocks. Connect as shown on this generic wiring print. Check the wiring diagram for terminal numbering details on your specific breaker. The only major difference between the SP and SPS installation is how the gas density transducer is installed. On the SPS, shown here, the decision was made to install directly at the fill port. A custom adapter was fabricated. Door clearance was the only size constraint, so a close 90 was used. If the breaker requires a gas fill-up, the transducer will be removed and after the fill-up will be reconnected. The optimizer 2 will recognize the density increase as a fill operation and adjust the database and forecast information accordingly. No interaction with the optimizer 2 is required. The completed optimizer 2 installation on the SPS is shown here. Installation took about 2 hours. Setup is easy. The best way to program multiple optimizer 2 units that are being installed on the same breaker type is to use a thumb drive USB memory stick. A memory stick library can be created covering breaker models of interest. This saves a huge amount of setup time and makes the whole process easy and straightforward. Most parameters are selected from pull-down menus. This part of the screen selects values that measured times are compared to for alarm purposes. These settings are common to 3-cycle breakers. This part of the screen sets up the SF6 density parameters. Here, the warning and lockout limits for SF6 gas are entered along with the sensor type. Digital true density sensors are standard with the Optimizer 2, but analog temperature compensated pressure sensors giving a 4 to 20 milliamp signal can also be used. The Optimizer 2 offers many benefits. It will totalize the lifetime use of SF6, making EPA reporting compliance easy. It will obviate the need for offline circuit breaker testing. First trip information will show any degradation in performance over the years. It also migrates the SF6 density integrity function toward the active and predictive smart grid realm. From the system operator standpoint, the major benefit of the Optimizer 2 is the detection of incipient failures in circuit breakers. This lowers the risk and cost of maximizing equipment uptime. Avoiding the equipment failures that create sensational news is more important than ever. The interrupter here will cost the utility over $200,000 in unplanned expense. Thank you. If you have any questions or need more information, please contact Incon PRS at 800-872-3455.